Hi everyone, I'm Danlu. I'm honored to represent our whole team to introduce our work, NER, Physical Virtual Multimodal Generative NFT with a Rarity model. Our work is a commission work for the school NFT platform. Let me first show a demo video of it. So NER stands for NFT-enabled rubbing. Before we dive into the work, I'd like to show an overview of 8 samples of NER generated by different users with Rarity scores. So nowadays, NFTs are increasingly emerging into public view. It is necessary to consider NFT as a sustainable trading model for media arts with audience interaction as a symbiosis community. We present a design architecture of a multimodal NFT with generative patterns triggered by sensors. By designing various 3D mesh attributes, such as eye patterns and fur colors of a roving bird, we generate a series of different NFT 3D artworks. We also demonstrate our experience with the generative system, together with the Rarity scoring model that could be used to evaluate the heterogeneity of NFT collections. We commissioned a factory to produce a batch of physical birds for us. Each physical bird comes with a small bag on its back, which is used to store an NFC card. NER collectors can obtain a redemption code by tapping their phones with the NFC card stored in the bag and entering our app to paste the code, which will give them one chance for the generation of a virtual bird. Our server receives the signal from the user and directly detects the user's internet status to ensure each redemption code is redeemed only once. It checks the status of each redemption code. If the code is the first time redeemed, the NER app generates a unique virtual bird NFT. If the code is already redeemed, our app directly displays the existing NFT. Here are some UIs of our app. As shown in the figure on the left side, there is an input box for the users to paste the redemption code. Also, the instructions of the redemption are also displayed. And if the user's phone does not connect to the internet, the NER app displays a warning as shown in the middle figure. If the user's phone is connected to the internet and the code is not redeemed yet, the NER app shows a shaking egg and the redemption instruction, as shown on the right. We have also investigated into a few different Rarity models commonly used to calculate the Rarity score. The trait Rarity model works by only comparing the rarest trait of each NFT item. The average trait Rarity model averages the rarity of all traits. The statistical Rarity model multiplies the rarity percentage of all traits to calculate the overall rarity. The Rarity score model first takes the inverse of the rarity percentage of each trait as the Rarity score of each single trait. Then the model adds up each Rarity score calculated previously as the overall Rarity score for the entire NFT item. This is the model we pick in our app to calculate the Rarity score. Our design architecture considers 6 different parts of virtual traits from top down, namely the hairstyle, the hair color, the eyes pattern, the beak color, the feet color, and the background color. We define the beak color and the feet color to have 2 variations, and the hairstyle has 3 variations. For the rest of the traits, namely the hair color, the eyes pattern, and the background color, they all have 4 variations. We also define the rarity percentage of all these variations. With all of these 6 traits, NER has 768 variations in total. As mentioned previously, we are using the Rarity score model, with which to calculate the total trait score, we need to sum up each single trait score. For example, the rarity percentage of the hairstyle is 15%. So we take the inverse as the single trait score of the hairstyle. For other traits, we are doing the exactly same calculation. So as a result, we get the total score of this NFT item. You can see the calculated result is exactly the same as shown in the app. Now I would like to talk more about the implementation details, since I am from the technical background and I was fully in charge of this part. The model of the NFT bird is made using different 3D modeling softwares. The mesh of the bird and a series of hairstyle is made using ZBrush. Maya is used to add UV maps to the models. The fabric model is created using Marvelous Designer. After we prepare the models and the UV maps, we use Substance Painter to paint a range of basic colors and apply different materials to the models. The model is then sent to Unity for the next stage of work. We export the Unity project as a mobile app containing 3 stages, namely the redemption stage, the generation stage, and the save stage. Users need to first log in with their email address in the redemption stage, because the redeemed codes are linked to the email address for their future review. Each redemption code consists of 10 characters, including digital numbers and both uppercase and lowercase letters. This can produce 8 times 10 power 17 distinct combinations. However, we only produced 1,000 codes this time for the school commission work. Each code has 2 states, namely unused and redeemed. Our server tracks the state of each redemption code. Whenever an unused code is entered for a new NFT bird generation, its state changes to redeemed. The close pattern is achieved using a shader. The color of the shader is controlled by a gyroscope. A gyroscope sensor measures the angular velocity. As shown in the bottom left figure, the angular velocity along the X, Y, and Z axis controls how much red, green, and blue colors appear, respectively. The speed of the changing pattern is controlled by the accelerometer sensor, which measures the acceleration of the phone. There's an instruction during the generation stage asking the users to shake their phone for 2 seconds. With the 2 seconds, the sensors can collect data and personalize the clothes for the generated NFT. The save stage starts once the generation of the NFT is done. During this stage, All data related to the shader properties and the trait generation from the previous stage is written into a JSON file and stored on the server under the logged-in account. If the user of this account enters an already redeemed code again during the redemption stage, all the stored data is fetched to directly display the generated NFT to the user, skipping the generation stage. That's it for the presentation. I'd love to answer any question you may have.
Thank you. So I'm just wondering, what did you mention which blockchain you're using for this project?
Oh, I didn't mention in the presentation because actually this is like a commission work for the. So we are actually using the the blockchain from our university. So we for us, we don't need to worry about how to put that on the blockchain.
Thank you.
Thank you.
So that is actually really interesting. So your university provides the infrastructure for doing those projects, and you can use them and program onto that?
Yeah.
Okay, so with this, did you have technological support from your university?
No, because actually I am from the technical background, so I can do all of this coding myself. And the school already built the platform, so for everyone, if you want to just upload, for example, an image or a video, you can just do it. And if you want to upload something like this kind of 3D model with shader or materials, you can just do it and then upload to the school, the blockchain of the university. Thank you.
Il est possible d'avoir...